Okay guys, we are going to start off by making a model for 12 times 13. What I would actually ask my kids to do is get their base 10 blocks and make a model of the number 12. And what I'm looking for is that the kids in 4th grade can actually, instead of using unit cubes for 12 and counting out 12 of them, have enough number sense to know they can pull a tens rod and two ones like this. Okay? Then I'm going to ask the kids in their problem, they've made the model 12 and I want them to repeat it 13 times. This really solidifies that we're adding up 12 13 different times. So I am already kind of putting my own version of the model together right here. And you're going to have to excuse me, I'm doing this one-handed, which is not particularly easy. As the kids go in and start to make their models of 12 over and over and over again, what I really want the kids to discover is that they can exchange a few of these pieces of unit cubes and tens rods for something of the same value but less pieces essentially. Most of my kids will make their model and it will finish up looking like this. This is not wrong, but it's not where I want the kids to be in order to understand how we go from a model to this on paper and pencil. Okay? So I asked my kids, hey guys, is there anything you can do to exchange some of these pieces for things that are of equal value but less pieces? And what I'm hoping they'll discover right off the bat, and some already will have, is that they could take out these unit cubes. For every 10, they could replace it with one of these. So I'm hoping that they will have enough common sense, or number sense rather, to count out 10, 2, 4, 6, 8, 10, and pull these out and just insert a tens rod in here. And that they would do the same thing for this top row because there are 10 more up here. Again, this is going to be really important here in a second when they see the algorithm connect and how we're getting the products for it. Then I will ask them a second time, okay, I like what you did. There's one more thing I can do to make my model fewer pieces. And the next thing that I want the kids to recognize is they could count out 10 of these right here and exchange them for a 100s flat. It's the same value, just fewer pieces. Now, are they wrong if they use this model instead? No. This is going to actually make it a little bit easier to understand if they have it together like this. So I want to get everyone on the same page if I can. Now I'm going to ask them to write out their array, and I want them to recognize that no matter what kind of exchanging we did, we still have 10, 11, 12, and we still have 13 across. So I want them to make the connection that even though we exchanged pieces, it's still the same multiplication problem. Now I tell the kids, okay, we're going to add up what we have. Let's start with the different sections of our model. So I usually start off by saying, what's the greatest amount that we have sitting here in our pieces? And they'll say the green piece or the 100s flat. Or they'll shout out 100, which is just the same answer. And so I have them write down 100. Okay, this is a value right here of 100. Then I say, what about this little section right here in the tens rods right here? How many tens rods do you have? And I want them to say they have 3, which is a value of 30. Okay. Notice how I'm lining them up in the place value order because I'm getting prepared to add these up, just like I would do in a standard algorithm. Okay, I continue on and I say, what about up here? How many are here? And they'll say 20. And I say, how many unit cubes? And they should be able to count up 6. Some of my kids will actually look at it this way. They'll see 36 and they'll see 20, which is phenomenal. It's great. I want them to be able to do that because that tells me they're combining some of our individual products, and that's what we want. In 4th grade, and in math in general, these numbers here that we multiplied are called partial products. We teach the kid the vocabulary word because we want them to know that this is not the final answer, but that they are part of what makes the final answer. And when they add this up, they're going to have 156, which is the answer to 12 times 13. And of course, we celebrate. Now, we do this over and over using models. And here is the reason why. I'm going to come over here and I'm going to work the basic algorithm the way you and I were raised to do it, or what my kids affectionately joke around and say, the real way. Lots of parents come up to me and say, when are you going to teach our kids the real way? Why are you teaching them new math? And this is exactly what I want to do this video for. It's not new math, it's just an explanation for why and the hows we're getting all of these answers and numbers over here. It doesn't do them any good if they don't know where they came from. So in our regular algorithm, you and I were raised to write 3 times 2 is 6, okay? I want them to know where 3 is twice. In their model, they can count out 3 2 times. And they got 6 here. So I want them to know where the 6 is coming from. And then I really want them to understand this particular part right here. We're multiplying the way we were taught. We were taught to multiply 3 times 1, and we would write 3 down. I need them to understand that it's not 3 times 1. 3 times 1 is 3. This 3 is in the tens place. This 1 is in the tens place. So we're really multiplying 3 times 10 and getting 30. Well, the kids can now see where we got 30 from. There are 3 tens rods right here. I want them to make the connection that this is a place value change. We're using tens pieces now, okay? Now, my big joke in class is when I was in 5th grade and we were learning to multiply 2 digits, my teacher would tell me to come and bring a 0 and write into this place value. I did it because that's what I was told to do. I had absolutely no concept of why I put a 0 here until I got into college. And that's a big joke because my kids think it's hysterical. I didn't understand multiplication until I got into college. But it's true. When my teacher told me to put a 0 here, she wasn't explaining why. We were taught now, after we put our 0 down, to do 1 times 2 is 2. Well, I want the kids to know it's not a 1 in the ones place, it's a 1 in the tens place. So we're really multiplying 10 times 2 and getting 20. And the reason we put the 0 here is so that we show we have no ones and that our 2 ends up in the right place value. They should also be able to come over to their model and understand how they're getting 2 sets of 10. And then last but not least, we were taught to multiply 1 times 1 is 1. Okay? I want the kids to know that the ones are in the tens place. And then it's really 10 times 10, okay? And that gives us 100. Hey guys, where do you see 100 in here is what I ask them. Oh, I see it right here. 10 times 10 on this green piece right here makes 100. So when they come to the standard algorithm, they're understanding that all of this is just lots of simple little multiplication problems or partial products that we get to add up, and that the algorithm is actually a shortcut. It combines 4 partial products into 2. We will get the same answer and it will work out just perfectly. As they see this model, we make several more. And then they're able to make the connection to the standard algorithm. I hope you guys understood what was going on and the whys. Here in a second, I'm going to show you on the next video how we teach them this method on paper. Have a great day. Thanks.